Hi students, I'd like to show you a video of some chemical reactions to show how the chemical properties of certain elements repeat in a predictable pattern. So lithium is a soft gray metal at room temperature, and when it's put into water, a chemical change happens. So the first thing that you'll notice is that lithium starts making bubbles. Those bubbles are filled with hydrogen gas. Now hydrogen gas is flammable, so if you take a lit match near it, you can see that it sets the hydrogen on fire. This chemical change will continue to happen, forming bubbles of hydrogen gas until the lithium is used up. Another element is sodium, which, like lithium, is a soft gray metal at room temperature. It forms bubbles of hydrogen gas, and when you take a lit match and hold it nearby to the sodium, it will set that hydrogen on fire, so that fireball you see is the burning the hydrogen gas from the bubbles. Potassium has an even stronger reaction. When you put potassium into water, you can hear that pop and see that burst of flame, which happens because the chemical change produces so much heat that it literally sets the hydrogen gas bubbles on fire by itself. No match required. Rubidium is another element, but this chemical change has a little bit more power. And finally, my personal favorite, cesium. So on the periodic table, you notice that elements with similar chemical properties are put into the same group or the same vertical column. So for instance, up here on the left-hand side, you can find the element lithium, the first one in the video. Then below it, 8 elements later, you see sodium, an element that acts very much in a similar way to lithium. Then 8 elements later, you get potassium, which again, those chemical properties are repeating in a predictable pattern. 18 elements later, you get rubidium, and another 18 elements later, you get cesium. So using the periodic table, all the elements in the same column, the same group, will have similar kinds of reactions. You can even use this to predict the reactions of elements that you don't know about or don't have access to. So for instance, the next element in that row is called francium. In real life, francium is extremely rare. There's only about 2 grams of it in the entire planet at any one moment. So that's why they couldn't put it in the video. But using the periodic table, we can predict what would happen if somebody were to get some francium and put it into water. You can imagine the news the next day. Local science teacher dies because he throws a chunk of francium into a bucket of water and it explodes. So this is one way of showing how the periodic table can be used not only to state the names and symbols of the elements, but also to categorize them based on how they react.